Hi everyone, this is Adiba from KAIST, and it's my pleasure to present our work, Time2Stop, Adaptive and Explainable Human AI Loop for Smartphone Overuse Intervention. The rapid advancement of technology has empowered the use of mobile devices to engage in almost every aspect of our daily lives. While bringing us convenience, smartphones also introduce numerous potential risks. Smartphone overuse may adversely affect individuals' physical health, mental well-being, and social wellness. Many research studies have been invested in designing and experimenting with various digital intervention tools and techniques to regulate smartphone overuse. These mechanisms promote digital well-being by informing users about their usage statistics, showing notifications, or restricting access to app or app functionalities. While these methods were beneficial in enhancing self-awareness and reducing smartphone usage time, they primarily intervene based on simple criteria, such as while opening a specific app, at predetermined intervals, or after achieving a daily usage goals. In other words, interventions based on these basic criteria may be suboptimal as they do not consider context and variability in human behavior. In mobile health, just-in-time adaptive interventions, or JITAI, was introduced as a promising technique that provides right amount of support at opportune moments while dynamically adapting to users' internal and external context. Traditional JITAI-driven intervention systems incorporate a predefined set of rules, such as users' location, to determine delivery time or content. There have been many works leveraging AI to deliver interventions, as AI can analyze large amounts of data and identify patterns that cannot be captured through manual rule setting. Moreover, in the human AI loop setup, users can offer feedback to the AI, allowing the model to enhance its predictions and personalize interventions. However, there is a very little work that explores empowering AI-based JITAI with a human-in-the-loop setup. Employing JITAI-based interventions for smartphone overuse is challenging, as it requires a real-time ML pipeline and prompt adaptability to users' constantly evolving habits. Despite the accurate predictions with black box AI models, they often face challenges of interpretability and transparency. This gave rise to the recent advances of Explainable AI, or XAI, to help users comprehend AI systems' decisions, thereby fostering user trust and collaboration with AI. Recent intervention systems employed XAI to personalize education, manage stress, and fitness goals. However, there is no prior work integrating XAI into JITAI-based smartphone intervention. It can improve intervention delivery transparency and handle confusion caused by unexpected interventions, and also cultivate users' trust via human-AI interaction. To address these gaps, we design and implement Time2Stop, an intelligent, adaptive, and explainable smartphone overuse intervention system grounded in JITAI principles while taking user feedback in the loop. Time2Stop consists of two major human AI loops: inner loop, annotated by green, and outer loop, annotated by blue. In the inner loop, contextual and app usage data is sent to the cloud server, where the server extracts features, performs model inference, and generates explanations. Then, these model predictions and explanations are sent back to the user. If the prediction is overused, then an intervention window pops up, where in an outer loop, user can provide feedback, and this feedback is used to update the model at the server side. Once the server finishes updating the personalized model with the user-provided feedback, this adaptive model is then used to make predictions and generate explanations. The Time2Stop architecture consists of two primary components: the ML pipeline for predicting smartphone overuse and the intervention design displayed to users upon predicting overuse. Let me start from explaining the ML pipeline. The ML pipeline for predicting smartphone overuse consists of four key components: feature design, label collection, model update, and explanation generation. We define 5 passive sensing feature categories for feature design, capturing smartphone overuse behavior through user interaction, physical activity, dynamic contextual factors such as time of the day, social context, and location. These categories, drawn from existing literature, form the foundation for extracting features for our machine learning model. Time2Stop utilizes supervised learning to predict smartphone overuse, requiring label data for model training. Label collection follows the ecological momentary assessment, or EMA methodology, serving two main objectives: to build an initial ML model and to facilitate adaptation over time. The ML model update process incorporates user feedback on the intervention as new labels. Coupled with relevant contextual data, these inputs facilitate continual model adaptation, tailoring to each individual user and dynamic contexts. Lastly, we offer user explanations derived from model predictions to enhance users' understanding of the ML-based intervention system's decisions. These explanations are generated from the top features contributing to an overuse prediction, providing both high-level and detailed insights for user convenience. The JITAI-based intervention system aims to provide accurate and timely support while accommodating shifts in user context and conditions. Following these principles, we design our intervention to consist of four main components: intervention mechanism, intervention timing, user feedback to update the model, and providing model explanations. Previous research in smartphone interventions primarily relies on notifications or app access restrictions to engage users. However, interventions via notifications are often easily bypassed, and overly restrictive measures can frustrate users, potentially resulting in adverse effects. To balance between intervention efficacy and usability, we adopt typing-based intervention mechanism. The intervention task is illustrated in the figure on the right, where the user is prompted to enter the randomly generated task. The user can continue using the app only if the entered digits are correct. Our ML model decides whether to intervene or not based on users' current context and app usage behavior. Unlike previous JIT-based methods that triggered interventions upon app launch or when usage exceeded a predefined threshold, our approach considers both the launch and usage duration. It initiates feature extraction and model prediction both at app start and periodically during usage. To adapt to dynamic shifts in user context and app usage behavior, we update each individual's ML model regularly. A direct approach to gather new labels involves creating specific prompts for label collection, but this could significantly reduce system usability. To overcome this, we've incorporated user labeling into the intervention interface itself, allowing users to easily click to indicate phone overuse. For model explanations, we highlight the categories of essential features such as app use, activity, and location. The interface displays only the top 3 critical feature categories for ML model inference, minimizing confusion by hiding less relevant ones. For users desiring further insight, detailed descriptions of low-level features are accessible via the Click to See More button. To assess the adaptability and explainability, we designed 4 distinct intervention types: control, a probabilistic baseline; personalized, utilizing machine learning but without updates or explanations; adaptive without explanations, similar to personalized, it's ML-based and adapts regularly based on the user feedback; finally, adaptive with explanations, or Time2Stop. This approach offers both adaptation and comprehensive explanations. The interface for control, personalized, and adaptive without explanations is exactly the same. Only Time2Stop has additional explanations section. We conducted an 8-week field experiment with 2 weeks of modeling, 1 week break, 1 week baseline, and 4-week interventions with 71 users. Our results showed that the adaptive interventions are more accurate and show higher receptivity compared to control and personalized baselines. In addition, adding explanations further enhanced accuracy and receptivity. We also observed that adaptive models had the highest positive slope, improving intervention receptivity over time. Adaptive models also helped users to reduce the number of visits made to the unproductive apps. Lastly, adaptive models received higher preference rankings and better subjective rankings in terms of time accuracy, perceived effectiveness of the interventions, and level of trust. To summarize, we created and deployed Time2Stop, an intelligent, explainable, just-in-time adaptive interventions to reduce smartphone overuse. Our real-world deployment results show that the adaptive interventions are more accurate, have higher receptivity, reduce the app visit frequency more effectively, and have higher preference rankings compared to the baseline methods. Moreover, adding explanations further enhance the intervention accuracy and receptivity. We envision that Time2Stop can inspire researchers in other domains where enhancing AI-based JITAI with human-in-the-loop feedback and explanations can extend its benefits beyond smartphone overuse. Finally, I'd like to thank the whole Time2Stop team for great collaboration and contribution. Thank you for your attention, and I'm happy to take any questions.